Hello, and welcome to the Interpreting Results lecture. We've talked about analyzing results, what they mean, how to report them in APA format, but now we're going to actually get into interpreting results in the broader sense. Having scientific consensus means that there's just an agreement among scientists about an answer to a research question. And this is established through multiple empirical studies providing similar answers. So this isn't just one or two studies or a handful, this is possibly hundreds of them. And they're all coming to the same consensus of, hey, this relationship is present, or here is the answer to the research question in question. So here's an important quote. It kind of makes sense. Actually, it does make sense. So do not interpret a single study's results as having importance independent of the effects, reported elsewhere in the relevant literature. The thinking presented in the thinking presented in a single study may turn the movement of the literature, but the results in a single study are important primarily as one contribution to a mosaic of effects. So think about research and the answers to research questions as each individual study is just one piece. And whether you retain or reject the null, that's just part of a broader picture. And that one retention or one rejection could be just the 1 in a million, or it could be the trend that a lot of the other studies have also come to conclude. But ultimately, it is just a drop in the pond. It is a piece of the mosaic. So of course, when we have testing, when we're finding these results, there's always the outcome of there being errors. There's always the possibility of errors being present. So the outcome of a null hypothesis test is an educated guess, essentially. We don't know for certain because there's always the possibility of some sort of error. These are known as type 1 and type 2 errors. So if you get these confused as to which one is which, it's okay, because I do as well. It's kind of hard to remember. It's kind of hard to keep track. But type 1 error is when you decide a relationship is real, when it's really due to chance. So what you're doing there is rejecting the null hypothesis by saying the relationship is real, when in reality, it actually should have been retained. And then a type 2 error is deciding a relationship is due to chance. So you retain the null hypothesis when it's actually real. So you should have rejected for a type 2. You retain when you should reject for a type 2, and you reject when you should have retained for a type 1. And here's a little chart to help you. So we have the decision of the false null, meaning that you reject the null hypothesis, or it's true. If you reject the null and it's false, good job, you did the right thing. If you reject the null and it's true, you made a mistake. You made a type 1 error. You retain a true null, you made a correct decision. And if you retain a null when you should have rejected it, you've made a type 2 error. So why do type 1 errors happen? Well, they just kind of do. It happens 5% of the time when we say we reject the null when we actually should have retained it. It occurs about 5% of the time. That is no mistake. Oftentimes, that is what we set alpha to at 5%, or alpha equals 0.05. So again, we're saying that there's no relationship in the population, but the sample that we had could have just had extreme results. So we could have gotten, the sample that we have obtained could have been in like the outreaches of the total population, and we just happen to find one that happened to be significant. But as a whole, that research question has a retained null hypothesis. So we'll talk about this in the next lecture, but publication bias and the file drawer problem, that's also where this comes to play. Publication bias is where we tend to publicize in scientific journals the significant results. It's sexy to have a low p-value, to say, ooh, there's a relationship here. We're going to reject the null hypothesis. But it turns out a lot of those tend to be published with more frequency than, let's say, the ones that are not retained, or the ones that are retained. Because again, Low p-values are sexy. We want those to be publicized. However, maybe we shouldn't do that. The file drawer problem is the opposite, where we tend not to publish the results that are not statistically significant. So you retain the null, no one knows about it because you're not publishing it. Journals are more likely to publish statistically significant results as opposed to not. So why do type 2 errors happen? Remember, this is when you say you retain the null, but you actually should have rejected it. Well, the relationship could be weak. You could have a small sample size. And also keep in mind of power. That is a statistical method we use to determine how many participants we need to see if there's a relationship. So if you're thinking, oh, we're having alpha set at 0.05 and we're anticipating a large effect size, then you would need to have X amount of people in your sample to determine that with certainty if you should retain or reject the null. So type 2 errors do happen. A lot of times they're based on just not having a large sample size and just not really accounting for that. So what do we do? For type 1 errors, we just replicate studies. We keep doing studies to see if that significance was an accident or if that was actually something that should have happened. Type 2 errors, again, we increase the sample size and the relationship strength. So generally increasing the sample size is a little easier than the relationship strength because we need stronger manipulations for the relationship strength as well as a greater control of extraneous variables. And again, extraneous variables are the things that affect our dependent variable across the board. So both types of errors are to be kept in mind when you're interpreting the results of a single study. You know, you read one article, they say they have statistical significance or they don't, whatever the case may be, kind of take it with a grain of salt. They could have an error in there and not necessarily they're trying to. Obviously, no one's trying to make errors, but it's always a possibility. So how do we get around that? What do we do? If one article can't be really taken as like, oh, facts, although it's science, there's really no such thing as facts. They're ever changing. Again, empirical studies provide us more information about things we didn't know previously. So science is ever changing. There's hardly ever such thing as a hardened fact that never changes over the course of time. But what do we do about having one article and thinking, well, I don't know if I should really think of this as, does this really answer the research question or did they make an error? Well, there's a little thing called meta-analysis. And meta-analysis is taking a boatload of studies. So while I mentioned that each study contributes to a mosaic of the results of that research question, having a meta-analysis allows us to look at all of the studies within that answer that research question and make a more logical, a more statistical conclusion regarding what is the answer to the research question. Now, looking across studies is always easy when the results agree with each other. Oh, we reject the null. We did too. We rejected it. We rejected it. I retained. We got a lot more rejects though, so it's okay. But what happens when it's a mixed bag? What happens if you have about half of the research saying, yeah, there's a relationship here, and the other half saying, nope, there's not? Well, we look into it. Now, keep in mind that there's always going to be variability across studies. We can have studies asking the same exact question, but they can produce different results. Maybe some get retained, some are rejected, what have you. But there's always possibility of just how they conducted their study that makes those results different. So they could have operational definitions of their variables, or they could have different operational definitions of their variables. Some might choose to go with the self-report route. Here's a survey or questionnaire. Some might go with the behavioral route. I'm going to examine you. I'm going to observe your behavior and make tallies based on, how often you do this or do that or what have you. Different procedures, excuse me. Different procedures. Maybe people said, obviously you have different operational definitions that kind of goes hand in hand with having different procedures. You're not going to really have to worry about gathering participants to observe them if you're going to send them an online questionnaire. So different procedures could also increase the variability across studies. Different kinds of participants. Obviously, we're going to have different participants across the board. A lot of times we have convenience sampling. So we have what's around us or who we have access to in our academic bubble. How far our fingers can stretch out to touch other people. No, I don't like that. How far our reach is so we can reach out to other people. That's a little better. But, if you're living in a rural area, chances are the kind of participants you're getting are going to be a lot different from more urban areas. If you live in, the middle of nowhere in Nebraska, you're going to probably have a lot different participants in your study than you would in even Fresno, California. Sampling error, that's always a cause as well. You can just have errors when it comes to your sampling and how it's not true randomness in terms of applying them to your conditions, or obviously to gathering participants in general. We don't really have a true random sample, because again, a random sample means that every single person in your population has an equal chance of being in your study. So you have a random sample of college students would mean, okay, so of the 100 million, or I don't know how many college students are in just the United States alone, but let's say it's 100 million, you have to have each of those 100 million have the exact same probability of being in your study as the person who lives right next door to you in your dorm or what have you. Chances are that's not going to happen. So sampling error is always an issue as well. So when we write about multiple studies, there's two types. We have narrative and quantitative. So narrative is kind of something we're more familiar with. It's more traditional. It's something you guys are working on. It's describing and integrating previous research in a story format. You guys read your 7 articles and you put them together in your introduction section, and it served as a narrative to describe what the research currently is in that field or relating to that research question, to those variables. And it's great for generating theories and hypotheses because, hey, ooh, look what this person did, or look what these people did. Ooh, let's piggyback off of that. And that's leading us to have this research, there's a hole in the research. And so this current study, the one that I am writing, is going to address that hole. So it's great for generating theories and hypotheses because it kind of leaves it open to what's next. With meta-analysis, this is a more quantitative view of a literature review. Well, it's certainly newer. It's not something that's been around for, generations on end. And instead of describing it like a story and like, oh, so-and-so did this, this, and this for their study. Next paragraph, so-and-so did this, this, and this, and they found this. This now, quantitative literature reviews or a meta-analysis is describing and integrating research statistically. So it's not really looking into like, oh, this one study did such and such a thing. Now it is taking a step back and analyzing everything, all of the research in that field. And then this is better for testing specific hypotheses because you have a full picture of the literature at that point. You have a full picture of the research to where you can have, all the ins and outs of that particular research question. And so you can test for more specific hypotheses to jump off from that. So Smith, Glass, and Miller did a meta-analysis, and they wanted to combine hundreds of studies, and they wanted to look at different therapies for different problems. So what did they do? Well, they described each study in terms of its effect size. So remember, this is Cohen's D or Pearson's R. Cohen's D is between groups. Pearson's R is quantitative relationships, correlation. And they combined these effect sizes statistically. So they're looking at using different therapies for different problems. And they used all of the effect sizes, all of the Cohen's D. Oh, maybe we used behavioral therapy versus cognitive behavioral therapy. Oh, one study did that and they had an effect size of, D equals 0.4. Another study, maybe they're using more holistic approaches to therapy versus cognitive behavioral approaches to therapy, D equals 0.52 or whatever. They're combining all of these Cohen's Ds to find an average of everything, which is kind of big. I mean, it's meta, so there you go. So how do you do this? Well, first you got to identify the relationship of interest. if you're going to be gathering all the research, you kind of need to know what research you're gathering. So once you identify that relationship that you're looking into, then you start gathering all that research. So this is published as well as unpublished. That's where it can be difficult. That's where you guys start getting into file cabinets and looking into those studies that weren't published, possibly because of the lack of statistical significance. Now, depending on what your research question is obviously going to depend on which effect size it is. So, or which sort of effect you're going to be looking into. Is it Cohen's d for a difference between groups, or is it Pearson's R for that correlation between quantitative variables? So the big difference with meta-analysis, so when you think about when you did Pearson's R for your practice studies, back in the day, each individual person had 2 scores based on their survey results. Maybe you're looking at, stress and academic confidence or something. They took a stress questionnaire and scored 7 on average, and then they took the academic confidence questionnaire and scored a 6 on average. That 7 and 6, those points line up on your scatter plot, and each point represents an individual person. Oh, that's my next door neighbor. Oh, that's my friend. Oh, that's my cousin I don't really like talking to, or whatever. With meta-analysis, each of those individual points on a scatter plot, if it's Pearson's R, or each individual point that's made up to make the average for Cohen's d that you're comparing, instead of those points being individual people, each of those points are individual studies. So it kind of takes a big step back where it's like, oh, you're really looking at the whole picture at this point. It's a lot bigger. Again, it's meta. So it's pretty hard to wrap your head around in some ways, but at the same time, it's also very informative. So, excuse me. Like I said, the differences in studies might account for variability. So this includes, how people operationally define their variables, their procedures, the participants they have access to, etc. So Smith, Glass, and Miller, again, the people that looked into the psychotherapy and the different aspects of it with the Cohen's d of 80, or well, 0.8. They looked into things that didn't matter too much. They saw that the type of therapy didn't really matter, the length of therapy, and the therapist's training didn't really matter that much. So you always have these moderator variables that, even though they're present, they don't really matter that much. Like, again, type of therapy, length of therapy, therapist training, etc. They found that when they were looking into their meta-analysis, those 3 things didn't really make too big of a difference. So finally, to conclude, meta-analysis by default is not just another study. It's not just another article that someone published out of nowhere saying, look what I did, Mom. It is, hey, look at all these hundreds, possibly thousands of articles. So it's literally not just another study. It is like another 1,000 studies or what have you. So if it is well conducted, if you make sure that you're doing your statistical analysis properly, you're keeping it consistent, you're being vigilant in terms of conducting a meta-analysis, it can provide the answer to your research question. That research question that you found all these articles for, you found all the answers for, and you're bringing it together in a meta-analysis. If you guys were, when you guys were looking for articles and you found an article that was a meta-analysis, it seems like the gold mine. Oh my God, everything's here. They talk about all the research. But if you're just, it's kind of a big task to take on to kind of analyze or to summarize a meta-analysis in your final project papers. I'm sure if anyone had a meta-analysis, they're like, oh my God, why is this so different than everything else? It's because it literally is so different than everything else. It's not talking about the research and the literature on that topic in a story-driven format where it's describing things that are going on currently and, oh, here, now we have a hypothesis. It's literally breaking down the effect size of every single article, every single research study in that field, and finding what that effect size is there. So it shouldn't be doubted based on an individual study with meta-analysis, again, because it is all of the studies. You can't just say, oh, it's just one study and we're done. Oh, I don't know. Is there a type 1 or a type 2 error? Well, You have all of the studies there. So that's my brief lecture on meta-analysis and interpreting results. So keep in mind, you know, looking at one article, there's always that possibility. There's always that possibility of an error, be it type 1 or type 2. But when it comes to, put your hands down, sweetie. But when it comes to a meta-analysis, we get the full grasp of it. But keep in mind that, you know, we do these research projects in our class and we think, oh man, this is, oh, that kicked my ass. That was really, that I have a lot bigger picture. I have a lot better understanding of the research now. Well, yes and no. With a meta-analysis, it also includes every single person who felt that way. So we're not going to do a meta-analysis in this class, bit overwhelming, but keep in mind that's out there. So if you do want to continue on with research, look into those meta-analysis for your research question of interest. It could provide you a lot of good information. So that's all I got for you today. So don't forget to like and subscribe. Oh yeah.